Hi everyone. Today in this video I am going to solve some examples on Leibniz theorem. So without wasting our time, let us move to the green board. So example, if y is equal to sine into bracket m sine inverse x, prove that 1 minus x square into yn plus 2 is equal to 2n plus 1 into x yn plus 1 plus n square minus m square into yn. For this, let y is equal to sine into bracket m into sine inverse x. Next, what is differentiation of y1? Differentiation of y is y1. What is differentiation of this sine term? Differentiation of sine term is cos into bracket this m sine inverse x. Okay. Now what is differentiation of this m sine inverse x? M is constant. Differentiation of sine inverse x is equal to 1 divided by root 1 minus x square. Now transpose this root 1 minus x square to the left hand side. y1 into bracket root 1 minus x square is equal to m into cos into bracket m sine inverse x. Sine inverse x. Now we know that on squaring we get, okay, if you square what we get, y1 its square is y1 square, root 1 minus x square, root 1 minus x square its square is only 1 minus x square is equal to m its square is m square and cos its square is cos square, that is cos square into bracket m sine inverse x. M sine inverse x. Now as we know that cos square theta, how can I write cos square theta? Cos square theta we can also write it as 1 minus sine square theta. In place of theta we have m into sine inverse x. So this is m into sine inverse x is nothing but theta. So by using this formula we can write m square into bracket 1 minus sine square theta, and theta value is m into sine inverse x. This is bracket complete, is equal to m square. Left hand side we have y1 square into bracket 1 minus x square, and now here this is bracket 1 minus, what is the value of sine m into sine inverse x from equation 1? From equation 1, y is equal to sine into m sine inverse x. So sine square is nothing but we can write it as y square. Now differentiating again. Differentiating again. So y1 square write as it is. What is the differentiation of 1 minus x square? Differentiation of 1 minus x square is equal to minus 2x. Now plus second term 1 minus x square as it is. What is differentiation of this first term y1 square? Differentiation of first term y1 square is 2y1 into differentiation of y1 is y2. Now towards the right hand side m square is constant, and then what is the differentiation of this 1 minus y square. Differentiation of 1 minus y square is equal to minus 2y into y1. Now dividing throw out by 2y1. Dividing throw out by. Dividing throw out by 2y1. So if we dividing through out by 2y1, here we are left with minus xy1 plus 1 minus x square into y2 is equal to minus m square into y. So these are the remaining terms. So first I will rewrite this equation. First I will write this term, that is 1 minus x square into y2 minus xy1 plus m square into y is equal to 0. Now differentiating n times by using Leibnitz theorem. Differentiating n times by Leibniz theorem. Okay, first I have to differentiate this 1 minus x square into y2, where this 1 minus x square is v and this y2 is equal to u. So nc naught, I will write first nc naught. Nth derivative of y2 is yn plus 2 and 1 minus x square as it is. 1 minus x square as it is plus next term nc naught is over. I will write nc1. Here we can add minus 1 so that you will get yn plus 1. What is differentiation of 1 minus x square? Differentiation of 1 minus x square is minus 2x plus next nc1 is over. I will write nc2. Here you can add minus 1 so that you will get yn only, and differentiation of minus 2x is equal to minus 2. Next term you will get 0. So this is the nth derivative of 1 minus x square into y2. Now similarly, what is the nth derivative of xy1 with minus sign? So first I will write minus outside, starts with nc naught. In case of xy1, y1 is nothing but u and x is nothing but this is v. So I will write nth derivative of y1 is yn plus 1 and v term as it is, that is x as it is, plus next term is nc1. Here if you add minus 1 you will get yn. And what is differentiation of x? Differentiation of x is 1. This is the nth derivative of the second term, plus last term is m square is constant. Nth derivative of y is equal to yn and that is equal to 0. In this case we can write the value of nc naught. Nc naught value is 1. nc1 value is equal to n. nc2 value is equal to n minus 1 divided by 2 factorial. Similarly, this nc0 value is 1 and nc1 value is equal to n. If you substitute, you will get, I will write directly, that is in first term nc0 value is 1 means we are left with 1 minus x square into yn plus 2. In second one nc1 value is n and then this minus 2x. Minus 2x I will write here only, that is minus 2x and yn plus 1. Next, in next term this 2 factorial and this 2 get cancels. I will write NC2 value is, that is n into n minus 1 divided by 2 factorial, and 2 get cancelled. So we are left with minus and yn only. And then here NC0 value is 1, multiplying with 1 into yn plus 1 into x is minus xyn plus 1. And then multiplying with this minus into this sign is minus. NC1 value is n, the remaining term is yn, and at last you will get m square yn is equal to 0. Now collect the terms containing n plus 2. The term containing n plus 2 is only 1 minus x square into yn plus 2. So that is 1 minus x square into yn plus 2. Okay, now collect the term containing n plus 1. The term containing n plus 1 is minus 2xn yn plus 1 and minus xyn plus 1. So first I will take minus xyn plus 1 common. Then here we are left with 2n and plus 1. And now collect the term containing yn. If you take the term containing minus yn common, or you can take minus and nyn common, then here we are left with n minus 1, and in this term we are left with plus 1 plus m square yn is equal to 0. And here minus 1 and plus 1 get cancels, means total you will get, total you will get 1 minus x square yn plus 2 minus xyn plus 1 into 2n plus 1. And here minus n into this n is minus n square, and this m square I will write as it is, and again you can take y square common. So m square minus n square yn is equal to, this is minus sign, is equal to 0, which is the required solution. Next example, if y is equal to x square minus 1 whole raised to n, prove that x square minus 1 bracket complete yn plus 2 plus 2xyn plus 1 minus n into bracket n plus 1 yn is equal to 0. I will write first y is equal to x square minus 1 raised to n. If you differentiate with respect to x, y1 is equal to, so what is differentiation of this x square minus 1 raised to n? We can write it as n into x square minus 1 raised to n minus 1, and differentiation of x square is equal to 2x. Then y1 is equal to, I will write this 2x here, so that is 2nx, and then the remaining term I will split in the form of x square minus 1 raised to n and x square minus 1 raised to minus 1. y1 is equal to, this is 2nx, x square minus 1 raised to n. Transpose this term to the right hand side. If you transpose to the term to the right hand side, you will get x square minus 1. And now on Now by using this given equation we can write it as 1 x square minus 1 x square minus 1 into y1 is equal to 2nx, and this is y. From the given equation this value is equal to y, so I written that is 2nxy. Differentiating again, differentiating again. So first term x square minus 1 as it is. What is differentiation of y1? Differentiation of y1 is equal to y2 plus y1 as it is. Differentiation of x square minus 1 is 2x is equal to, in this case, 2n as it is right hand side, and then into bracket. We have to differentiate x and y by using product rule. So first x as it is, differentiation of y is y1 plus y as it is, differentiation of x is 1. So this is x square minus 1 into y2 plus 2x y1. If you simplify this and transpose to the right hand side, you will get, if you simplify you will get 2nx y1, transpose to the left hand side minus 2nx y1. Similarly, multiplying to the last term with this 2n into y is equal to 2ny, transpose to the left hand side minus 2ny is equal to 0, and then we can write it as x square minus 1 into y n plus 2 as it is. From these two terms you can take minus 2 and xy1 common. If you take minus 2xy1 from this term as common, here we are left with n. And from this term if we take minus 2xy1, this plus we can write it as minus into minus. One of the minus I have taken common means here we are left with minus 1. And at last minus 2ny is equal to 0. Now differentiating n times by using Leibnitz rule. Differentiating n times. Differentiating n times by Leibnitz rule. Leibnitz theorem I will write. Leibnitz theorem. So for the first one, in case of first one, yn plus 2 is u value and this x square minus 1 is v value. So first I will write nc naught. Sorry, here I have written plus 2. This is only y2. This is y2. So nc naught as it is. Nth derivative of y2 is equal to yn plus 2 and x square minus 1 as it is. So now I will write directly nc naught is over nc1. Here if you add minus 1 you will get yn plus 1. X square minus 1, its differentiation is 2x. Then plus nc2. Add minus 1 here you will get yn. Differentiation of 2x is 2. So this is nth derivative for the first term. Now what is the nth derivative for the second term? This is second term. And in case of second term, minus 2 n minus 1 is constant. Minus 2 n minus 1 is constant. And then we can write into bracket. What is the nth derivative of only x and y1? In this case, y1 is u value and x is v value. So nc naught, nth derivative of y1 is yn plus 1, x as it is, plus nc naught is over, write down nc1. Here you can add minus 1, you will get yn. Differentiation of this x is equal to 1. So therefore this is the nth derivative for the second term, minus what is the nth derivative for the last term, where minus 2n is constant, the remaining term is y and its nth derivative is yn. Right hand side you will get 0. Now substitute the value for this n c naught value is 1. So we are left with x square minus 1 into y n plus 2. What is the value for this nc1? nc1 value is n and this 2x. So total we can write it as plus 2nx. The remaining term is y n plus 1 plus. Now what is the value for this nc2? nc2 value is n into n minus 1 divided by 2 factorial. This 2 factorial and 2 get cancels. So at last we are left with only yn into n minus 1. Okay, then here nc naught value in the next bracket, nc naught value is 1 and outside we have minus into 2n minus 1 multiplying with this term. So total you will get minus into bracket 2n minus 2 x into y n plus 1. Minus 2 into n, minus I have written outside only, and 2n minus 1. And for the next term nc1 value is equal to n into this y1 is ny1. I will write that is n y n, and with minus this 2n minus 2. Okay, then last minus 2n y n is equal to 0. Now collect the terms containing y n plus 2. The term containing y n plus 2 are, that is x square minus 1 y n plus 2 plus. Now collect the term containing y n plus 1. This is 2nx y n plus 1. Then here also you are having minus 2n minus 2, and only these are the two terms containing y n plus 1, where you can take minus x y n plus 1 common, or I will take x and y n plus 1 common, then write down the remaining terms. Here we are left with only 2n, and here we are left with this complete term. So minus 2n into minus 2n, minus into minus is plus 2. Okay, then collect the terms containing yn. The term containing yn are, this is the first term of yn. If you take n yn common, if you take n and yn common, n and yn common, the remaining terms are n minus 1. Here if you take this n and yn common, the remaining term is minus into 2n minus 2. So better I will write here, that is plus n yn is common, we are left with n minus 1, and in second case here we are left with, that is minus into 2n. This minus into 2n is minus 2n, and minus into minus 2 is plus 2, and yn if we take common, at last here we are left with minus 2, where plus 2 minus 2 get cancels. Here plus 2n minus 2n get cancels. So x square minus 1 into y n plus 2 plus x y n plus 1 with 2 remain, that is 2xy n plus 1, and in this case plus this n into minus 2n is minus n minus 1, and n into yn is equal to 0. So the same term again we can write it as x square minus 1 y n plus 2 plus 2xy n plus 1. Here you can take minus common, minus n yn into bracket 1 plus n is equal to 0, which is the required solution.